So we have our first talk. It's going to be, I think, one of the most exciting talks in this session is going to be about what's going to be new in Net 7. And our speaker is Joe, and he's waiting in the background, I guess.
Yeah. Hi.
Hey there. How are you doing?
Yeah, good, thanks.
Yeah, it's pretty exciting time, and thanks so much for joining us. And yeah, we are in anticipation hearing what's new in the Net 7 and what are some exciting things we can start using today to make our lives easier, more productive, and help us build better apps.
Okay. So yeah, let me introduce myself. My name is Jan. I am a software engineer at Microsoft. I work in a team that implements the features into C#. So today I would like to show you what's new in C# 11. It's actually what we have implemented, although before that, the design team at Microsoft discusses all those features at length, thoroughly discusses proposals from community or proposals from Microsoft employees, and when everything is specified correctly, we go to implement those features. And yeah, I actually work from Prague, Czech Republic, but the rest of the team is based in Redmond in Seattle. So they are like -9 hours for me, which is funny to work with.
Well, I believe the beauty of Prague makes up for it. So I have been there. It's a very nice city.
Yeah, it's great.
Yeah, it's pretty cool to hear like first-hand experience. A small question to you: how many times you have such a situation where you're having a lunch and someone will come to you? You know, there is a very cool idea I have about C#. Can you please implement it for me?
Well, not that often, fortunately, because most of my family doesn't even understand what I do. Yeah.
Well, they don't know that they are hosting a genius in their house, so
Exactly.
Cool. So good luck with the presentation, and the stage is yours.
Okay, thank you. So I have prepared some demos for you.
Amazing.
The first one, let's start with a simple class person. It's a person that has first name, middle name, last name. It's probably an American or person. In other cultures, you might have different name segments, And as a good C# developer, I have nullability enabled, so I can annotate this string to be nullable. So middle name is not required, but these two properties should never be null. And we can actually see that the compiler gives me a warning here that the first name might contain a null value. So it's not guaranteed that it will be non-null as I declared it. So for example, here, if I create an instance of the person, I don't set last name, so it will actually have last name as null, which is a violation of this null annotation, right? So that's a standard thing. Usually it can be fixed, by creating a constructor. For example, I could create a constructor for first name and last name, and then everyone creating instance of this class would have to fill in those things, and then they can, optionally, even include middle name or something. So that's one thing, that's one way, but it can be, it's not the best in all cases. For example, if I would have a lot of derived types like a developer, which is a special kind of a person. I need to override the constructor, right? Call the base run, and imagine I have lots of derived classes and I add a new property and new parameter here. I would have to add it to all those classes. So it's another thing to maintain, even though Visual Studio can generate those constructors for you, you still have to maintain them. So, you know, not having constructor and using this object initializer, which as a way to initialize the object is sometimes very useful. And so another way to suppress these warnings is, you could set some default value, for example, an empty string, but now that's also kind of a hack because this person will have an empty last name. We probably don't want that. Or we could even use null here, which just shifts the warning here. So we can use bank. And yeah, so that's another hack because now the last name will still be null and you will get a null reference if you try to use it, but there are no warnings. So yeah, let's get rid of this hack. And so this is where the new feature of C# of C# 11 comes in, which is you can mark some properties as required, right? You put required in here and here, and suddenly the warnings go away because now the person is required to have first and last name, and it's guaranteed by the compiler that it will never be null. And we actually get an error here that we saying we didn't set last name. If we do that, everything is fine, no warnings, no errors. And if we don't set one of those required properties, it says this error that property last name must be set in the object initializer. That's this thing where you can set properties, or attribute constructor. So that just means that if person was an attribute, for example, and I would use it like this, I would also have to set these properties here in attribute constructor. So this, like this, for example. So this required modifier applies both to object initializers and attribute constructors. And yeah, so that's a nice way to make your, it's nice with nullability mainly. And yeah, another thing I wanted to talk about is if you, for example, imagine, so let's fix this first. And now imagine I would like to clone people, right? Because that sounds cool, although maybe dangerous. And so I could create a constructor that would take an existing person and just copy its first and last name, or I could copy even its middle name probably. Let's just do first and last name, the one required, right? And since I created this constructor, I still want to create people normally, so I have to declare the default constructor. Okay, and now I would like to clone the existing person, so I do that, but as you can see, the compiler still complains about first name and last name not set, even though I set them in the constructor. But the compiler doesn't know that. It doesn't look into method bodies or constructor bodies. The implementation could be in different assembly and so on. So you have to tell the compiler somehow, and it's possible to use attribute sets required members. The compiler that this constructor should set all required members, and the warnings, the errors go away. You could even, use some sort of reflection to set all properties. It wouldn't matter if you don't set them. That's on you. Although the nullability warnings are still there, so it kind of catches some errors for you. Okay, so that's the required modifier. And with that, let's move to another demo I have for you. So here we have a simple numerical algorithm. It takes a list or array of values of integers and sums them up, so very fancy algorithm. And yeah, imagine I now would like to use doubles here, for example. I would want to pass a double, so this would be an array of doubles, but I cannot use this algorithm. So the typical way to do this, even for example in the standard library in .NET, when there are numerical algorithms and we want to support more types, we would just copy paste the function, and just change the type everywhere, like this, for example. And so, the code is almost the same, but we have to change the type. Now the plus operator works on doubles. Now this is actually converted to double, but otherwise it's the same algorithm, but we usually had to do that in older versions of C#. But in what we would ideally like to do is make this just generic function, where t would be any number, and we would replace all the types, all the ints with t. And yeah, ideally we would want this to work, right? But operator plus cannot work on t. And so 0 also cannot be converted to t. So we have constraints in C#, so we would like to say t is a number, and we actually can do that in .NET 7, like this. And now, actually, operator plus is defined on t because it's defined on inumber. You can see that it's defined on inumber through some other interfaces, but we can see it's really here, and it uses the new feature, which is the possibility to have static abstract members on interfaces and also static virtual members. So, previously you could have only normal virtual members on interfaces, but operators are static in C#, so we couldn't have operators and we couldn't be generic like this. And so this new feature allows that. And one other way it surfaces here is we can just write t dot and use static members of the type. For example, 0, we want to use 0 here, right? So this will be integer 0 if t is integer, double 0. And t can be even any custom type, like a matrix, for example, can behave as a number. So this would be a zero matrix, and we would sum matrices here. So this way we can write generic algorithms very easily in C#. And if you go back here, I can show you. If I go to definition of number, that's the new interface added in .NET 7. It's kind of complex. If we go to number base, we can see there is lots of interfaces it implements so that it accommodates every need. For example, there is this abstract member 0, and previously we were in addition operators, so we have plus, and there's actually also one new feature where you can define checked plus operator separately, which is a plus that will be used if you are in checked context. By default, it just calls the normal checked operators, unchecked operator plus. Sorry. So yeah, that's just another feature that was implemented as part of generic math in .NET and C#. And this is not about just math. We can even here we can see that the number implements one thing. It's always implemented, all numbers always implemented formatable interface, right? So you could call toString on an integer, double, and even other things than numbers, right? And now I have to go back again. There is a new interface, parsable, which is like the inverse of formatting, right? So it must be static because it creates an instance of the type, and that's also why the t-self generic parameter is here, because we don't want to return iParsable from parse. We want to return integer or double. So having this interface allows us, for example, if we had strings here, let's just cheat a little bit and say we have a string, we can now call t.parse, parse the string. It also takes format provider, let's put null. And now we have a generic way to parse strings into t's, which can be integer, double, whatever. So, one thing I forgot is to show you that this algorithm actually works. So let's run this. It sums the numbers here and gives us 21.5. And this is now a double version of the algorithm. If we removed the double, we would have int version of the algorithm and it would show 15. So so this is a nice way to make your numeric algorithm more generic. And even if you yourself wouldn't want to use this, it's nice also for library authors. Like even .NET Standard Library can use this now, and it makes the library smaller, so your apps are then smaller and so on. And okay, now that's for this static abstract members and static virtual members. And let's look at another feature here of C#11, which is a list pattern. So in recent versions of C#, we introduced different kinds of patterns, and the newest one is list pattern. So let's say I want to be more declarative here, like functional programming almost. So I will rewrite this into one expression, right? I will see what's in values, match on it. So do a switch. And let's say I would want to match on an array that has length 0, and in that case return a 0, right? So that's something I could do before in earlier versions of C#. But now if I wanted to match on array that's length 1, I would have to just do this, for example. Like sum of array of length 1 is the first element, right? That's not very declarative. So what can we do with list patterns is just write this. This means an empty list. And here we can write, for example, 1. So that would match a list or array with element that has value 1. So you can do, for example, like this. But of course, we want to be more versatile here. So we would extract the first element and just return it, because sum of list of one element is just the element. Just as an example, I can show we can use more complex patterns here. All the ones that already existed. For example, we can match for number that is greater than 1 and less than 10, for example. Done something here. It's also quite smart. So, for example, now it tells me that I don't handle all possible values. For example, that the list of length or array of length 2 is not covered, and if I write a weird pattern like this, it tells me that it cannot be satisfied because no number is greater and lower than 1. So yeah, it's the analysis of this switch is quite smart, but let's fix this back into our sum function. And so we can continue, right? We can match a list of 2 elements, which we would add, and we could continue, go on, right? But we can also be more recursive here. So we would add 2 dots, which would extract a slice of the array from us. So if I would want to write it like this, I could. This would match the first element, and this would match the rest of the elements. So I would sum the first with sum of the rest. So this is a nice recursive algorithm, and I can show you it still works on integers. It still works also on doubles. So yeah, it's a nice way to, be more declarative in some cases. And one thing I didn't tell you is this slice actually can match even empty arrays. So if I had an array of 1 element, this could match the first one, and this would be an empty array. So actually this clause is redundant, and fixing that, if I reorder it, it tells me that this is not necessary, so I can remove it. So yeah, that's a nice way of having patterns around lists. It's very declarative, and the switch analysis also helps you quite a lot there. Okay, that's all I have for this demo. Let's move to the next one. It's about string literals. So historically in C#, we had 2 types of string literals, just the normal string literals like you see here. They are good for simple strings, but if you want to write anything complex like an XML, which I have here, you have to escape everything, right? So for example, if I want to add quote into it, or I would want to add a new line, for example here, I would have to write \new line. Or if I wanted to write a backslash, I would have to write 2 backslashes. So for example, if I run this, I have to switch and run this, I see that the escaped quotes are there. There's a new line and 1 backslash, right? So it becomes kind of confusing once you use more complex strings. So that's why we have a verbatim string literal, right? Where we don't have to escape almost anything, but we still have to escape quotes. So for example, if I wrote this, the backslashes are not escape characters. They are written. They are written into the output exactly as I wrote them and the input, but the quotes are halved. If I wanted to have two quotes in the output, I would have to write 4 of them here. But I can do some nice things, like for example, write new lines into the string, and nicely format my XML like this. But if I wanted to, for example, indent this, or these spaces are there, so it's kind of rigid in how you can use it, and still you need to escape quote. So there is a new feature in C#11 where you can write string literals. Let's put this back for a moment. So you do that by using 3 quotes at the beginning and at the end. Now you don't have to escape anything. So if I have 2 quotes here, they are actually written exactly as I that. So, you know, I can write exactly what I want and it will be visible in the output. And even I can write backslashes, I can write, I can, you know, just show that I can write backslashes and anything. And I can have this multi-line, but I actually have to put multi-line here, new line here, and new line here to make this multi-line. There is, it cannot be like mixed. I cannot have this, I cannot have this, but it doesn't matter. This new line and this new line is actually not in the output string. So it's actually a nice way to format your code. If you wanted to have the first new line, for example, you could put it there, but it's not there by default. And yeah, the other way this is nice is I can format my XML, for example, like this, right? It just works. And what's really nice about raw string literals is I can do indentation. So if I indent here, this whole indentation will be removed. I can see that it's still the same thing. And the way this works is it looks at the last quote here and removes the indentation before it. So it will remove 4 spaces here. If I move this here, then these spaces will be preserved in the raw string literal, right? They're here. So this is really kind of nice if you are in a method, for example. You can indent this any way you like, and it will look nice. So another thing that you might wonder is, you know, this is like the only string literal you will ever need, hopefully, because you don't have to escape any characters inside. You can do multi-line, you can indent, you know. But you might wonder what will happen if I write, you know, like 3 quotes here. It won't work, right? Because it will think it's the end of the literal. But I can actually add 1 more quote here and here, and suddenly it starts working because you know, I have 4 quotes, so I can have 3 repeated quotes inside. And if I want to add more, I could add more here and here. So, you know, you can write any string you want inside without escaping anything, and it will just work. You will just have to add as many quotes here as necessary. It's usually not necessary to add many, but, you know, if you want, you can. And this also supports, you know, this is nice, but it's only constant string, so it's probably not very useful on its own. But for example, imagine I want to have templates, so I would have some variable and I wanted to place it here, right? So I can do that. I can have this an interpolated string. The X will be substituted, so maybe it's hello world. And so, yeah, and again, you know, for example, in Roslyn, the implementation of C# compiler repository where I work most of the time is we have lots of tests, and those tests contain C# code, right? So, for example, I could have a test that has a class and some method, you know, and you know, this stops working once I add interpolation. So what can we do? Again, we can add another dollar, and now the braces are interpreted as braces normally, and if I want to interpolate anywhere, I can double them, and it works like this. So the X is still substituted, but the other braces are just literally in the output. And I can again repeat more and more of dollars, for example, if I wanted to, you know, have 2 braces in here, something like that. And I can even, you know, have brace around the interpolation like this. So now the heliport is inside braces because I have 3 of them and only 2 doors, and so on. So really versatile string literal where you can put any string inside and don't have to escape characters, you know, except of course for interpolation, but that's obvious. And so one last tip or trick I wanted to show here is if you are in Visual Studio and probably also other IDEs and have some complex string literal, for example, you have your tests already written using normal string literals or even verbatim string literals. So for example, you have a string like this, and it's maybe even more complex, like there can be many escape characters and so on, and you want to convert it to a string. So what you do is use a quick action. So for example, this light bulb or control dot, and use this convert to raw string action. You can even do this in the whole document project solution. So you can convert your strings to raw strings if that makes them more readable, for example. Although maybe it won't pass a code review, such a change, but yeah, you can do that. So, and it even nicely indents the string literal, removes the escape characters and everything. So yeah, that's raw string literals. Just use 3 quotes and do anything you like. And for one last feature, I have another demo here, which uses another new feature of .NET 7, generated regexes. So historically in C# you could have regexes interpreted at runtime. So you would declare a regex with some pattern like this one, and the regex library would parse the pattern and interpret it at runtime. Or it could be even compiled, but again, that would happen at runtime the first time you start the program, or not the first time, every time you start the program, the first time you use that regex, it would get compiled. So then the subsequent invocations would be more efficient, but still it would have to be compiled at runtime. So what's the new thing here is that we can generate regexes at compile time into a code. So, it should be faster and can be ahead of time compiled and so on. So how do you do this? You declare a partial method that returns regex, takes no arguments, and annotate it with this attribute generated regex. Put the regex here, and there is a source generator built into .NET 7 which generates code for you in the background. We can look here. It's actually really nice work because it even generates you a documentation command which explains the pattern, and even the implementation, if you look here, is really nicely generated so you can read it and understand it. There are even comments, you can debug through it. So, you can understand the pattern really nicely. It's a really nice source generator, but why I'm talking about this is a new feature in C#11, which is mostly useful for source generator, and that's a file modifier or file local types. So this source generator, needs to put this code somewhere. So it creates a class, myregex0 in this case, and all the code that source generators create for you is part of the program. So it's, it has to be, because this is, for example, implementation of the partial method. And so you can actually, without the file local types, you could see the my regex 0 type. And what's worse, you probably wouldn't use it by your own, but you could have a type of the same name accidentally already in your code, and the source generator would generate it again. That would be a conflict, right? So, and even if that wouldn't happen and you would think you can use it, and then depend on some implementation detail, that's also not good. So what does file modifier does is it declares this class as visible only in this file. So it can be used by the source generator here to implement the regex, but you cannot actually see it. So if I would declare a variable here of the type, it would be an error. It shouldn't actually be even visible in the IntelliSense here. It was visible before, but that was probably a bug. But it shouldn't be visible if there is a file modifier. So yeah, that's another feature of C# 11, mostly useful for source generators. And that's actually it for my demos. I tried to select the most interesting features. There are a few more, and yeah, I hope you liked the features, you learned something new maybe, and I wish you happy using C# 11, and actually look forward to C# 12. We are already working on many features there.
Thanks, Jan, so much for the presentation. There are two things I learned from it. Number one, I learned a bunch of new interview questions that we can ask. And the second is that the only thing that the new pattern matching is not doing is putting a very nice morning coffee. The rest of the things it already covers, So yeah, it was pretty cool and pretty interesting. I have learned a couple of new things for myself. And thanks so much for bringing this up. And by the way, regarding the generic number constraint, back in I don't know, I believe 7 or 8 years ago, I was building some kind of calculator and arithmetic operation parser and all of that. And I had actually to do this myself. Of course, it was much simpler version, and the interfaces would only implement the operations that I needed. But it's pretty cool to see that it is finally a part of the language. And people who are doing a lot of method operations, probably people from finance world, would benefit from this a lot.
Yeah. Now, I mean, if you implement your own calculator, you will probably benefit. But even if you don't work with numbers, the standard library, uses this under the hood, so you will benefit transitively.
Yeah, and about the new row strings feature, it's pretty cool. And I had to struggle with it, especially when you in ASP.NET, when you generate components and you have to generate an HTML. Now it's going to be a much simpler task to do. You would have a really nice view of it without any kind of escapes and all of that. And the fact that you add an extra dollar, an extra quote to extend your buffer of escaping, it is also a pretty damn good idea,
Yeah.
I can imagine already a usage of this. For instance, if you write a Kubernetes Helm chart, for instance, everywhere there are those double quotes for referencing environment variables. So a good usage of adding another dollar sign for you to be able to write that down in your code. So it's pretty handy.
Yeah, it's really versatile. You can just add lots of dollars, lots of quotes, and
yeah. And is there any fourth feature perhaps that you haven't talked about, and it's something that you like?
some other feature of C# 11, or
yeah, what would you mention like the fourth most important feature for you?
oh, I would have to think because I'm now more focused on features in C# 12, but in
Or perhaps you can give us like a spoiler what C# 12 is going to look like.
well, I don't think it's known. You know, we sometimes work on features and they don't make it into the next version of C# because it turns out they are more complicated. For example, right now the work is started on rows and extensions. That's a very complicated feature. So it might or might not be in C#. I can't really say. So for C# 11, I would also say there is one interesting feature for people that do some low-level code or unsafe code, which is ref fields and ref structs. That's like, yeah, the other interesting feature for me, which allows you to do lots of interesting high performance computing in C#. So, you know, C# is like approaching C++ almost.
Oh.
If you want. If you don't have to use it, right? But if you are writing high performance code, like for example, if you would implement ASP.NET yourself, you want to have as many requests per second as possible. So, and you don't want to implement that in native language. So it can be useful to sometimes have the possibility to use these features.
Yeah, that's awesome. And one last question regarding the required attribute. Many of the times when I work with ASP.NET, you have those configuration app settings files, and you would have a mapping configuration object with all of those properties that you should specify in the configuration file. And of course, that configuration file is created on the fly with reflection, I guess. And many of the times when you use the nullable operator and you put the properties without like equals null an exclamation, it would complain that these properties are not going to be initialized, and you would have build warnings in your project, which is not neat. Anything you can suggest in those scenarios?
Well, actually, required will work there too. It will shut up those warnings. You don't have to use equals null anymore.
Perfect.
It's it's still, the configuration will be still created by reflection. So it's actually possible that there will be null because reflection can do anything it likes. It can even skip the constructor, But if the reflection code is implemented properly, it could look and see, this property is required. I will require the value to be there, and if it's not, I will throw an error. So, if the reflection code is implemented properly, you can use required there, and it will be also guaranteed.
I'll try it with the configuration files.
I'm not sure it's
Thank you.
Yeah.
Thank you so much again for spending time with us. And we are waiting for C# 12, and hopefully we'll see you next time in our NetConf speaking about C# 12. Yeah. Have a very nice day. Enjoy your day. Enjoy your week. And thanks again.